Welcome to this new video, where we will see how to use the Renewable Energy Library in Automation Studio. Today, we will focus on the illustrated tools and libraries that can be used to model and analyze solar energy systems. We will start by exploring the new Renewable Energy Library available in Automation Studio. This library contains all the components necessary to simulate photovoltaic systems. To access the Renewable Energy Library, we will go to New Project, open the Electrical folder, then Illustrated Components, and select the Motor Control and Renewable Energy template. The Renewable Energy Library is divided into different sections. The first section is composed of the mechanical components found in wind energy system. For the wind turbine, it will provide mechanical energy through a transmission. The second section includes environmental components to measure variables such as temperature, irradiance, wind. In the last two sections, we will find the electrical components including solar panels, batteries, and other essential devices for our circuits. In this practical example, I will show you how to use the components to simulate a solar panel system. In this project, we will model the current voltage characteristic curve of a solar panel under different irradiance conditions. For this, we will create a simulation circuit and see how the characteristic curve of the panel changes as we vary the irradiance. The first step will be to create the system in the document. We will start by inserting a solar panel. We will select a 24-volt polycrystalline panel. As we can see, we have polycrystalline and monocrystalline panels depending on the model we want to represent. By right-clicking and entering the component properties, we can adjust the tilt or incident angle, the positioning in the park, or any other parameter that affects its operation during the simulation. However, we must be aware that a solar panel alone will not be sufficient to simulate the energy generation. Just like in real life, to generate current, it is necessary to have an energy source that simulates the effect of the sun on the panel. For this, we will insert an irradiance generator. The connection between the solar panel and the energy source will be done automatically, without any connection needed. We will also insert an environmental sensor that will read the irradiance intensity during the simulation. As before, it is also not necessary to connect the generator and the sensor. We will insert a resistor with a movable contact that will simulate electrical consumption, and we will create the necessary electrical connections between the resistor and the panel. With this system, we just created the simplest setup you can have for photovoltaic system. Before starting the simulation, we will select the measurement elements to take readings of intensity and voltage. We will use a two-variable plotter to represent these readings. For this, we just need to drag the meters onto the plotter. We will start the simulation and play with the irradiation and the resistor value. As we can see, by representing the electric current as a function of the electric potential, we obtain a curve that is typical of Ohm's law. By inverting the curve and also representing the power, that is, intensity and power as a function of voltage, we should obtain the well-known photovoltaic characteristic curves. We simply need to vary the emitted power and the resistance. Now that we understand how this system works in simulation, we will next introduce a 24-volt battery. From the Renewable Energy section, in the Battery section, we will connect the battery in parallel and use a meter from the Simulation tab to analyze the charge percentage of the battery. A key component in photovoltaic systems is the MPPT algorithm, which optimizes the power we can get from the solar panel. I will show here how to configure and simulate the MPPT charger that manages the energy between the solar panel and the battery. We will insert one of them to observe its operation during the simulation. Additionally, we will see that if we insert an inverter, we can represent an electrical consumption system. The MPPT charger not only optimizes the power of the solar panel, but also manages the battery charge and the energy supplied to the connected loads. In this case, we see how gradually the battery charge percentage increases until it reaches a certain voltage where it is possible to supply energy to our consumption. We can observe how the charger keeps the battery at optimal levels and supplies energy to the loads as needed. Now that we understand how to simulate a system, we will also see that it is possible to simulate failures in the system, creating errors or malfunctions in some components and seeing what the effects on the system would be and what the various repair methods would be. To make a simple example, we will represent an electrical connection failure between one of these cables. In the simulation window, we will apply a malfunction to this cable using the failure tool. We will select Cut Cable and Validate. Now, when starting the simulation, we will see what effects on the system are caused by this failure. Here, the cable is crucial for the operation of electricity generation, and since it has been marked as cut, it is not possible to generate an electrical transmission to its respective consumption. By using the multimeters available in the Failure tab, we can study which component is having the malfunction. In our case, we already know where the failure is located in our system, so we will show that this failure is located using the disconnection tool and the continuity option on our multimeter. In this case, we see that having 0 at the limit, there is no continuity in the electrical section, so we would have located the failure. In addition to the cable break, there are many other failures that could affect an electrical system, such as current leaks or many other issues. This can be especially useful when wanting to perform simulations for technical training. With this, we have covered the fundamental aspects of photovoltaic park simulation using Automation Studio and its illustrated component library, from configuring panels to energy optimization with MPPT algorithms, to the integrated management of solar energy systems and modeling possible failures. For more information about the Automation Studio software, we invite you to visit our website. Thank you very much for watching this video.